All right, in lesson 10, we're going to be doing some modeling with inequalities. So we're going to see some words pop up that may lead you to the wrong symbol, but I want to kind of point out to you that it happens all the time, and hopefully that will make you not fall for the sucker trick. All right, so the words are at least and at most and no more than, or no fewer than, or no greater than. So the problem is here when people see, now don't jot this, I'm just going to go off to the side here and do some jotting. People see the word at least, they think the symbol less than, or they think less, like this. This is totally wrong. All right, now think about it. In terms of what you would do in your real life. If I said to you, I need to make at least $50 this weekend, that means I can make $50 or more than $50. So I don't want to use any less than symbols when I do that. And the same thing happens with at most. So this room can hold at most 30 students. That means 30 students would be fine, 29 would be okay, 28 would be okay, anything less than that's fine. But 31 students is the wrong thing. So lots of times people see at most and they try to do like a greater than because they think of things that are bigger than that number. All right, that's totally wrong and we want to stay away from that mistake. So let's erase all this and then we'll put down what we should write. Okay, so when you do see the word at least, you're going to think about what that means in terms of real life. At least $50 means $50 is okay, or more than $50 would be okay. So what we're going to say is I need greater than or equal to $50. And then the words at most mean exactly the opposite thing. So at most 30 students means I need less than 30 students or exactly 30 students. So I say less than or equal to 30 students. All right, no more than 80 people means I need less than 80 people, or I can have exactly 80 people. So less than or equal to 80 people. Up to, so the Superman roller coaster can hold up to 24 people. So that is 24 people or less. So we say less than or equal to 24. Now for each of these you would probably put some sort of variable. Here let's put M for money. Here let's put S for students. Here let's put P for people. And Superman will do the same thing. P for people. Alright, so let's read through this problem and kind of underline the stuff that's important. So we have Keith has $500 in a savings account at the beginning of the summer. He wants to have at least $200 in the account by the end of summer, and he withdraws $25 each week for food, clothes, and movie tickets. Alright, so what's important here? That he has $500 at the beginning of summer. That's important. That's his starting amount. So we're going to translate this and underline at the same time. Okay, he wants to have at least $200 by the end. All right, so this is our goal, or total, maybe. All right, he withdraws $25 each week. All right, and it doesn't really matter what he's withdrawing it for. I don't care about that. So this is our change. Okay, what's going on in the problem. All right, so we need to write an inequality that represents Keith's situation. All right, so first I need to do is figure out what is the variable. All right, the thing that changes in this problem. Okay, so he's got $500. That does not change. He wants to have at least $200. That doesn't change. But the $25 doesn't change, but the weeks, the number of weeks does change. So this is going to be my variable because it changes as time goes on. All right, so the number of weeks that has gone by is my variable. So let's do this. Let x equal the number of weeks. All right, and then we're going to kind of write an inequality. All right, so we have our starting amount. So Keith's situation, we've got the money that he has, and then we've got his goal. So let's try this. Let's say that he starts with $500, and then withdrawing $25 means he's subtracting $25, and then the word each means times, and our variable week. So I've got, let's read this carefully and make sure it makes sense. $500 minus $25, and then each week is because I've got this 25 times the number of weeks. Now, my goal is to have that be at least $200. Well, we saw above that the word at least means greater than or equal to $200. All right, so let's read that one more time with the 200. So I've got $500. I'm going to take out $25 each week, and the goal is to have this amount, the amount that's left in my bank, be greater than or equal to $200. All right, I walked through that slow so that I would be modeling for you the things that go through my head when I write an inequality like this or an equation like this. All right, you guys do the same thing, and life will get a whole lot easier for you when you're doing word problems. All right, so read through, underline what's important. Then the next most important thing is to think about what your variable is going to be. All right, how many weeks can Keith withdraw money from his account before he goes under? So again, how many is the question word. So we want how many weeks. And so again, I think you guys will set yourself up for success if you make yourself an answer blank that says blank weeks. Because I know that when I finish, my answer should be some number of weeks. All right, so let's take our 500 minus 25x is greater than or equal to 200. And let's solve this and get x by itself. Oops, I need to subtract 500. So let's get x by itself because x is the number of weeks. And once I know the number of weeks, I know what will happen. So that goes away. I've got my negative 25x greater than or equal to negative 300. And so I need to divide by negative 25. And remember, whenever you divide by a negative, you need to flip your symbol. So I'm going to actually do that part first. I'm going to change my symbol from greater than or equal to less than. All right, now that's okay to do in the course of the problem. Even though the problem started out as an at least, it's okay to switch the symbol when it happens in the natural course of solving. All right, so negative 300 divided by 25 is 12. So look, here's the deal. As long as x, or the number of weeks, is less than 12, Keith will still have his $200. So we say 12 weeks. So it says how many weeks can he withdraw? 12 weeks or fewer weeks than that, okay? So justify. Let's talk about this word justify real quick. The word justify, again, means just show work. Okay, so I solved my problem, and then I took that and I translated into what they want. That's fine for a justification. All right, next problem. So Caitlin gets groggy when she doesn't get the right amount of sleep. She's found that this happens if she gets less than 5 hours of sleep or more than 10 hours of sleep. All right, so we're going to assume for the sake of this problem that when I say less than 5 hours, I mean actually less than 5 hours. More than 10 hours of sleep, I mean more than 10, not 10. All right, so we're going to write a compound inequality that represents the number of hours. So it happens when she gets less than 5 hours of sleep or more than 10. All right, now notice that this does not say the word at least or at most, so I don't have to think about flipping those symbols. All right, so only if you see those words at least or at most, no more than, no less than. Okay, so write a compound inequality that represents the number of hours Caitlin must have slept last night if she's groggy this morning. All right, so one situation that could happen is that she slept less than 5 hours. So the first thing that we're going to need is some sort of variable. So let's say this. Let S equal the hours that she slept. Hours of sleep. Okay, so remember to name your variable. And so we're going to say she's groggy if S is less than 5, or, so we're going to actually write out the word or, if S is more than 10, so greater than 10. All right, so now what we're going to do is write a compound inequality that represents what she must have slept if she is not groggy. All right, so that's everything that wasn't included here and here. So Caitlin's not groggy. It makes sense if she gets somewhere between 5 and 10 hours of sleep. All right, so we're going to say that her sleep, let's write this in words first, must be between 5 and 10 hours. All right, so I think that word between is going to help us with our symbols. So we're going to take our sleep, and we're going to put that literally between the numbers 5 and 10. And now what I want to do is put the symbols in there, so I'm just going to pick a number that's actually in between 5 and 10 to kind of help me out. So let's pretend that 8 is our number, so that I can now compare 5 to 8. Well, if I compare 5 to 8, 5 is less than 8, so I'm going to put the less than symbol in here. All right. If I compare 8 to 10 this way, 8 is less than 10, so I'm going to put the less than symbol here. All right, and then we're also going to put the equal to bar underneath each, because we're going to assume that if she sleeps 5 hours, she will not be groggy, and if she sleeps 10 hours, she will not be groggy. I would actually go either way, so if you put them up here, that's fine, but probably better down here. It's a little bit more implied that it's down here. All right, so that's it. Now, I want you to be super careful, and I'm going to remind you that if you see the words at least or at most in a word problem for inequalities, what you're going to want to do is make sure that you think about whether that actually means less than or equal to or greater than or equal to. All right, 9 times out of 10, when you see the words at least or at most, it's going to point in the opposite direction of what you think. All right. So try some practice problems. Again, don't wallow in practice problems. If you're stuck, come ask for help.